Today we're going to be talking about section 7.1, integration by parts. And as always, we'll give you the basic background and foundational ideas of what to use, and you'll be able to move on from there by looking at any homework and quizzes. So remember, last time we looked at U substitution, one technique of integration, one method that works in some integrals to find an antiderivative. Integration by parts is another method that works sometimes, but not always. It works in certain types of questions, but not always. Again, the difficulty comes not so much in applying integration by parts, but later when we've got all of these different methods of integration, and you'll be asked to figure out first which method works, and second, apply it appropriately. But for today, we're going to stick with just focusing on integration by parts and practicing the basics of that. So if I take the derivative of a product, UV, derivative of UV is the first times the derivative of the second plus the second times the derivative of the first. All right, now what we're going to do is apply this funny sort of trick and take the integral of both sides. But the integral of the derivative gets us back to where we started. But if I anti-differentiate a derivative, I get back to where we started. And we're going to apply, we're just going to solve here, and we're going to move the v du over to the left. I'm going to write it like this. And this is our formula for integration by parts. And maybe it looks a little meaningless right now. But all right, so let's first look at some simple cases where we can apply our formula. I'm going to leave it up over here because it's something that hopefully you'll use enough that you can just remember. But here's our formula. The integral of u dv is uv minus the integral of v du. So that's our formula for integration by parts. Now remember that the formula came from the product rule. And we started with the product rule, and we derived this formula for integration by parts. So what we're going to use this for many times is a situation which looks like a product. If I have a product of two pieces, we're going to be able to use this formula to find an antiderivative. Not always, but if we see a product, then you should at least think that integration by parts is something that might work. All right, so I'm just going to go through this and explain it step by step. If I let u equal x and dv equal e to the x dx, then u dv is x e to the x dx. And so this piece in here, so this is u, and this is dv. So I have antiderivative of u dv, which is what our formula calls for, antiderivative of u dv. So I broke it up into two pieces. I decided which one was u, which one was dv. And so our dv is always going to include the dx, or the d whatever variable we've got here. And what do we need if I want to say it equals? Well, it equals u times v. Well, I got u, but I don't have v yet. But if I have dv, that's the derivative of v, then I can get v by anti-differentiating, by finding the antiderivative. So if I have dv is e to the x dx, then v is the antiderivative, which is just e to the x. What else do we need? Well, so now I've got u and v minus integral of v du. Well, now I still have v. I calculated v a second ago, but I need du. But du is just the derivative of u. So du dx, derivative of u with respect to x, is the derivative of x, which is 1. So just like we did with our u substitution, we're going to rewrite this as du is equal to dx. And now I've got everything on the right-hand side of this equation. I've got u, I've got v, and I've got du. And so let's apply our formula. If we apply the formula, uv minus the integral of v du, we get u, which was x, v was e to the x, minus the integral of v, which was e to the x, and du was dx. And the point is that this is now an integral that we can calculate without any more work. Because the antiderivative of e to the x is just e to the x plus c. And that's the answer to the question. So the trick with integration by parts is that if I want to evaluate an integral, and this is going to work, well, we get another integral back, but we hope that we get another integral that is easier to evaluate. And that's what happened here. We evaluated this formula. The second integral over here was simpler to evaluate. It was no longer x e to the x, it was just e to the x. Let's look at another one. Antiderivative of ln x over x squared dx. So we need to pick a u, and we need to pick a dv. Our dv is going to include the dx. We see two pieces. So, I see an ln of x, and I see a 1 over x squared. I sometimes see mistakes where people put an x squared somewhere and an ln of x somewhere. But when I multiply these two things together, it needs to make exactly what we're trying to anti-differentiate out. So the two different pieces are ln of x and 1 over x squared. All right, now here's the trick with this one. If I put ln of x right here, we'd need to find the antiderivative. Be careful, the antiderivative of ln of x is not 1 over x. The derivative of ln of x is 1 over x. So we would need to find an antiderivative of ln of x, which we actually have not talked about yet. Now, that's something that you didn't talk about in Calc 1. We haven't yet figured out what an antiderivative for ln of x is. We'll do that actually here today in just a little bit, but right now we don't know it, and it's actually a bit complicated. So putting an ln of x here doesn't really work for us because I get something more complicated down here. What I'm actually going to do is put my ln of x here in the u side, and the 1 over x squared on the dv side. If I have u, I need to take the derivative of u, which is 1 over x dx, because the derivative of ln of x is 1 over x. Now we need to anti-differentiate. Keep in mind that that's 1 over x squared, that's x to the minus 2. So the antiderivative is exponent goes up, divide by the new exponent. X to the minus 1 over minus 1, which is negative x to the minus 1, which is negative 1 over x. So now we apply our formula, uv minus the integral of v du. uv is minus 1 over x ln x minus the integral of v. Well, that's minus 1 over x, but we have a minus sign here, so let's turn that into a plus. 1 over x times, that's v. We also need du. du is another 1 over x dx. And so this is minus 1 over x ln x plus the integral of 1 over x squared dx. Which finally we can simplify because I can anti-differentiate 1 over x squared. In fact, we just did that. That's x to the minus 2. So this is what we see. X to the minus 2 becomes x to the minus 1 over minus 1, which is minus x to the minus 1 plus c. And this is our answer. And let's look at another one. Antiderivative of x square root of x minus 1. Again, we need to pick our pieces. And our general strategy should be to pick the pieces so that when we go to the next step, we've simplified our life. And that should be what we hope to do. Right? So we see an x, a square root of x minus 1. If I put the square root of x minus 1 here, by finding a derivative, well, it's a bit more complicated. But I guess the bigger problem is if I put x over on this side, finding an antiderivative makes it x squared. So it's actually increased in complexity. So most of the time when we have a choice, not always, but most of the time when we have a choice of just an x, I'm going to put just an x here. So that when I take its derivative, it goes to 1, which is much simpler. And put dv to be the square root of x, which is x minus 1 to the 1/2. Next level says take the derivative. Derivative of x is just 1. Don't forget the dx. Find the antiderivative. Well, this is just x minus 1, which is almost the same as just x to the 1/2. So the antiderivative is x minus 1 to the 3/2 divided by 3/2, which is multiplied by 2/3. Right? Again, the reason that works is because when I take the derivative, the 3/2 comes down and cancels. Exponent goes down to 1/2, and then I have to multiply by the derivative of the inside, but the derivative of the inside is just 1. And that's why I can apply this rule. So then, uv minus the integral of v du is x times 2/3 x minus 1 to the 3/2 minus the integral of v, which is 2/3 x minus 1 to the 3/2 times du, which is dx. And now we need to see if we can simplify that second integral. So this is 2/3 x minus 1 to the 3/2. I can pull that 2/3 out of the integral. And now we need to just integrate this, but again, that's not much different than what we just did a second ago. This is just like x to the 3/2, so the antiderivative is x minus 1 to the 5/2, exponent goes up by 1, divided by 5/2 is the same as multiply by 2/5, and we still have the 2/3. And our plus c. So the final answer looks like this. that's the basics for integration by parts. See you next time.